Next topic, which is on surds and indices. A raised to power minus n is nothing but 1 by a raised to power n. This means that if I have 2 raised to power minus 7, then this is equal to 1 divided by 2 raised to power 7. Similarly, if I have 2 raised to power 7 divided by 2 raised to power 5, this is nothing but 2 raised to power 7 minus 5, or this is equal to 2 raised to power 2. A raised to power 0 is 1, but 0 raised to power m is not defined, or 0 raised to power 0 is not defined. If I have something like 2 raised to power 5 and outside bracket I have 7, then this is equal to 2 raised to power 5 into 7, which is 2 raised to power 35, and this is not equal to 2 raised to power 5 raised to power 7. This is something which is very different from 2 raised to power 35. If I have 2 raised to power x is equal to 2 raised to power y, then x has to be equal to y. Given the reason that a is not equal to 0 or 1, so 2 is not equal to 0 or 1, because if I have 1 raised to power 10 is equal to 1 raised to power 100, but this identity here does not hold true for 0 and 1. Similarly, if a raised to power m is equal to b raised to power m, then a has to be equal to b. For example, if I have 2 raised to power 7 is equal to x raised to power 7, then x has to be 2. It cannot be any other number. Let's try this last question. If I have n here, so this value is actually root n, so nth root of a raised to power m. This can also be written as a raised to power m divided by n, or I take a raised to power m and then I can write 1 by n outside the bracket, or I can interchange. So 1 by n comes inside the bracket, m goes outside. It's one and the same thing. So there was a root n missing here. This a nth, this symbol means nth root of a. Let's try some examples here. So I have 1 divided by 216 raised to power minus 2 by 3 divided by 1 divided by 27 raised to power minus 4 by 3. So the first thing we do is change this power to a positive power. So I'll have 2116 raised to power 2 by 3 divided by 27 raised to power 4 by 3. So I'll just take the reciprocal and this negative sign in the power goes away. So first I'll take the third root of 216, which is nothing but 6. So I'm left with 6 square here, divided by, I'll have to take the third root of 27, which is 3, divided by 3 raised to power 4. So the answer is 36 divided by 3 raised to power 4, which is nothing but 81. So my final answer comes out to be 4 divided by 9. So this is the final answer, as 9 4s are 36 and 9 9s are 81. So let's try this next question. Find the largest among 4th root of 6, square root of 2 and third root of 4. It is very difficult to judge just by seeing at these three numbers at which number is the greatest. Before discussing on how to solve these kind of questions, I'll discuss a property. Let's say we have two positive numbers, 3 and 2. Now we know that 3 is greater than 2. Then this also means that 3 raised to a power m will also be greater than 2 raised to power the same power m, where m is greater than 0. So this means that 3 raised to power, let's say, 16 will also be greater than 2 raised to power 16. This is the property we'll use in this question. So all 6, 2 and 4 are positive numbers. So now we have a fourth root, we have a second root, and we have a third root. So what I'll do is I'll write 4, 2 and 3 here and take their LCM. So the LCM of 4, 2 and 3 is 12. Now what I'll do is fourth root of 6, I'll raise this to the power 12. Similarly, second root of 2, I'll raise this also to the power of 12, and similarly third root of 4 raised to power 12. So this gives me 6 raised to power 12 by 4. This property we've already discussed. 2 raised to power 12 by 2 and 3 raised to power 12 by 3. So this gives me 6 cube, 2 raised to power 6 and 3 raised to power 4. Now it is easier to find out which of them is the largest. 6 cube is nothing but 216. 2 raised to power 6 is 64 and 3 raised to power 4 is 81. So clearly this number, the first one, is the largest. So I can easily write here that this A part is the largest among all three of them. So this is an error. I'll have fourth root of 6 here and third root of 4 here. So the answer is the A part here. Let's try the next question. If x is equal to y raised to power a, y is equal to z raised to power b, and z is equal to x raised to power c, then find the value of a multiplied by b multiplied by c. The easiest way to solve this question is take x is equal to y is equal to z is equal to a is equal to b is equal to c equal to 1. Since nothing is mentioned that all these numbers are distinct or not. So if you put these values here, x is 1, y is also 1, so 1 raised to power 1 is also 1, so this equation is satisfied. Similarly, this equation will also be satisfied and this equation will also be satisfied. So we have to find the value of a into b into c. All of them are equal to 1, so the correct answer is the b part here. So we have solved the question just by substituting all the values as 1. Let's try this next question. I have 2 raised to power x minus 1 plus 2 raised to power x plus 1 is equal to 1280. What I'll do is I'll take out 2 raised to power x minus 1 common. So I'll have 1 plus 2 square inside the bracket is equal to 1280. So this is nothing but 2 raised to power x minus 1 multiplied by 5 is equal to 1280. This gives me 2 raised to power x minus 1 as 256. So I'll have 2 raised to power x minus 1 is equal to 2 raised to power 8 is 256. We've already discussed this identity. Since the base is same, the powers must be same. So x minus 1 is equal to 8 or x is equal to 9. So the correct answer option here is the C part. So let's try this next question. Here, as I see that 2 raised to power n minus 1 is the smallest, so I'll take 2 raised to power n minus 1 common from the numerator. This leaves me with 2 plus 1 inside the bracket. Also, I'll take 2 raised to power n minus 1 common from the denominator. So this gives me 2 square minus 2 in the denominator. This cancels out, so my answer is 2 plus 1, which is 3, divided by 4 minus 2. This gives me 3 divided by 2. So the D part here is the right answer. The next type of questions is finding the unit place of a number. Now whenever you have to find the units place, you don't need to multiply the entire numbers. All you need to do is multiply the unit digit of the first number with the unit digit of the second number with the unit digit of the third number. So 2 9s are 18 and 18 ones are 18. So I get 18 as the answer. So the units place is definitely going to be 8. Similarly, if I have the operation of addition, 7 plus 8 is 15. So the units place of this entire calculation is going to be 5. Now we have some raised to powers in the question. Again, we'll see only at the unit digit. So I have 3 raised to power 27 and here I have 7 raised to power 41. So what we'll do is we'll go by cyclicity, which we've discussed in the lecture on number systems. I know that 3 raised to power 1 is 3, 3 raised to power 2 is 9, 3 raised to power 3 is 27, 3 raised to power 4 is 81. So the unit digit here is 3971. 3 raised to power 5 is 243. So here 3 repeats itself again. So what I have here is that the cyclicity of 3 is 4, which means that after the fourth power, the unit digit of 3 will repeat itself. Similarly, 7 raised to power 41. So 7 raised to power 1 is equal to 7. 7 raised to power 2 is equal to 49. 7 raised to power 3 is 343. 7 raised to power 4, we don't need to write this here, but it would end with 1 because 7 3s are 21, and then 7 raised to power 5 again will end with 7. So again the cyclicity of 7 also is 4, which means I'll have 7, 9, 3, 1, again 7 will occur. So what we'll do here is 7 raised to power 41, I divide 41 by 4. This gives me 4 tens are 40, 1 as the remainder. This means that 10 cycles of 7 will repeat itself and then 1 is the remainder. So 1 remainder means that after completing 40 cycles of 1 till 4, it will again come at 7. So the units place of 7 raised to power 41 is nothing but 7. Similarly, 3 raised to power 27, I divide 27 by 4. I get 4 6 are 24. The remainder is 3. It means that 6 cycles will be repeated of 1 to 4, and in the 7th cycle I will have 1, 2 and 3. So this means that 7 will be the units digit of 3 raised to power 27. So I have 7 plus 7. This gives me 14. So the units place of this third question here is going to be 4. So the correct answer here is 4. Let's try these kind of questions wherein we have recurring terms. So I have 20 minus under root of 20 minus under root of 20 and so on till infinity. So how do we solve these kind of questions? I'll equate this entire thing to x. Now what I'll do is I'll square both the sides. I'm squaring this because this is the second root of 20 in the entire question. If it was the third root, I will cube it. So squaring both the sides, I get x square is equal to square on this of this term on the left side. So I have 20 minus 20 minus 20 minus 20 and so on till infinity is equal to x square. Now if we carefully notice, this is also till infinity, so this also is x. So what I get is 20 minus x is equal to x square, or in other words x square plus x minus 20 is equal to 0. Now this is the basic quadratic equation. So how to solve this? X square plus 5x minus 4x minus 20 is equal to 0. This gives me x plus 5 minus 4 and x plus 5. This gives me x minus 4 and x plus 5 equal to 0. So x is either equal to 4 or x is equal to minus 5, but x cannot be negative because this entire term is positive and square root of a negative number is not defined. So my answer is x is equal to 4, which is the C part here. Let's try another question. We'll solve it the similar way. I'll equate this entire thing to x. Again, because it's a square root, I'll square both the sides. So I have x square is equal to square of this term on the left hand side. This gives me 42 plus I'll be left with this term. which again can be put equal to x. So 42 plus x is equal to x square. Now I'll move all these terms to one side. So 0 is equal to x square minus x minus 42. I'll factorize this. X square minus 7x plus 6x minus 42 equal to 0. So this is x minus 7 plus 6 x minus 7. This gives me x plus 6 multiplied by x minus 7 equal to 0. So x either is equal to minus 6 or x equal to 7. Again, x cannot be equal to a negative number because this entire term is positive. So my answer is x is equal to 7, which is the A part here. So let's try this next type of question wherein we have to convert a recurring decimal into a fraction. A recurring decimal is a decimal which has a bar on top. So I have 0.143. This means that I can write 0.143, 143, 143 as many number of times. So 143 will basically repeat itself. That is why we put the bar here. The first thing you have to take care of is, does the bar start right after the decimal point or not? In this question, the bar starts right after decimal point, whereas in this question, it does not start right after the decimal point. So I'll discuss both these type of questions here. What you'll do is you'll equate 0.13 bar to x. Now you'll count the number of digits which are covered under the bar. So I have 1, 4 and 3. I have 3 digits which are under bar. So what you'll do is you'll multiply 0.143 bar by 1000. Now I've multiplied by 1000 because there were 3 digits under bar. If there were 4, I would multiply by 10,000. So this is equal to 1000x. So both the sides I multiply by 1000. So this will give me the answer as 143.143 bar is equal to 1000x. So now what I'll do is, this is equation number 1 and this is equation number 2. I'll just subtract the equation 1 from equation 2. So 2 minus 1. This will give me 143. So 0.143 bar here and here will cancel out and I'll only be left with 143 is equal to 1000x minus x, which is 999x. So x comes out to be 143 divided by 9, 9 and 9. So the correct answer option has to be B part here. This is not 1000. This will be 999. I'm sorry for the incorrect answer options. Now let's solve for this. The second question here. Here what we notice is that the bar does not start right after the decimal. Again, I'll equate 0.143 bar to x. The first thing you do in this type of question is bring the bar right after the decimal place. So I multiply this equation by 10. This gives me 1.43 bar is equal to 10x. Now we'll follow the same procedure we followed for this question here. I'll multiply this equation by 100 because I have only 2 digits under the bar. So this will give me 1.43 bar multiplied by 100 is equal to 10x multiplied by 100. So this gives me 143.43 bar is equal to, this is 100, 1000x. Now what I'll do is I'll subtract this equation number 1 from this equation 2 here. So basically I'm doing 2 minus 1. This gives me 142 is equal to 990x, or the answer is 142 divided by 990. 90. This is equal to x. So I've converted the decimal into a fraction. Let's try finding out the squares of the numbers ending with 5. It's very easy. The rule says 45 square will be equal to 25. You'll write 25 towards the end, and then since we have a 4 here, you'll multiply 4 with the next integer to 4, which is 5. So 4 into 5 is 20. So the answer is going to be 2025. Similarly, 35 square would be 5 is there, so you'll write 25. 3, the next integer to 3 is 4. So 3 into 4 is 12. So the answer is simply 1225. 105 square, again write 25. I have 10 ahead of 5 here. What is the next integer to 10? This is 11. 10 into 11 is 110. So the answer is 11025. Similarly, if we have 215 square, I'll have 25, and ahead of 25 here you'll just multiply 21 into 22 and write whatever the answer comes here. So it's going to be, if we solve 42 and 42, so this gives me 462. This is going to be 46225. Now we'll discuss squares in general. Let's say you have to find 102 square. We have a general formula which says base plus 2x, then this slash and x square. Now this base can only be either 10 or 100 or 1000 or 10,000, basically powers of 10. So here 102 is nearest to 100. So what base here is? The base here is 100. What is x? X is the addition or subtraction to the base. Here 100 plus 2 gives me 102. So x here is 2. Base here is 100. So what is the answer for 102 square? I'll have base, which is 100, plus 2x. So 2 into 2, which is 4. I'll mark this slash, and here I'll write x square. So x square here is 4. 2 square is 4. Now what you have to keep in mind is that the number of digits here after the slash, this slash here, has to be equal to the number of zeros in the base. The number of zeros in this base 100 is 2. So I cannot write x square as 4. I will have to write x square as 04. 2 digits here because the number of zeros in 100 is 2. So what is my answer? I'll have 100 plus 2 into 2 is 4 slash 04. So the answer is going to be 10404. 1014 square. So here the base is going to be 1000. 2x is going to be 2 into 14, which is 28, and x square would be 14 square. So I get 1000 plus 28 slash 14 square is 196. Now since 1000, the base here has 3 zeros and I have 3 values here. 3 values in the sense 3 digits in the value here. So this is perfectly fine. So the answer is going to be 1028196. Let's try 97 square. Again, here the base is going to be 100, but x here would be minus 3, as 100 minus 3 is equal to 97. So we apply the formula base plus 2x slash x square. Now x square is minus 3 square, which is 9. But since base has 2 zeros, after slash I need to have 2 digits. So this comes out to be 09. Base plus 2x means 100 minus 2 into 3, which is 6. So this gives me 9409 as the answer. This minus 6 because 2 into minus 3 is minus 6. Now let's try finding out 202 whole square. When we discuss this formula base plus 2x slash x square, I told you that base can only be powers of 10, like 10, 100, 1000, etc. Now the base can also be 200, but there will be slight change in this formula. So let's discuss by taking this example. So here I have base is equal to 200 and I have x is equal to 2. So the change in the formula is going to be, now I'll write base plus 2x. I'll multiply this first part by n and then slash x square. Now what is this n? N in this question is 2. Now 2, because 200 is nothing but 2 multiplied by 100, which is the nearest base of 10. So here I'll have 2 multiplied by, the base here is 200. 200 plus 2x, x is 2, so this makes it 4, and x square, which is 4, but since 200 has 2 zeros, here I'll write 04. So the answer will be 2 multiplied by 204 slash 04, which is nothing but 40804. Let's try another question. I have 2014 square. Again here the base is going to be 2000, x is going to be 14, and n here will be 2. Why 2? Because 2000 is nothing but 2 into 1000, which is the nearest base. So again I'll have base plus 2x slash x square. I'll multiply this base plus 2x into the index n. So I have 2 multiplied by 2000 plus 2x. 2x is 28. I have this slash, and x square, which is 14 square, is 196. Now since 2000 has 3 zeros and 196 has 3 digits, this is perfectly fine. So I'll have 2 multiplied by 2028 slash 196. So this gives me 4056196 as the square of 2014. Let's try finding out the square of 197. Again here the base will be 200, x will be minus 3, and n will be 2. So the answer is going to be 2, which is n, multiplied by the base 200 minus 2x, which is 6, slash 3 square, which is 9. So I'll have 9 here. So the answer is going to be 2 multiplied by 194 slash 9. So the answer is, I'll have 18 39809. I hope this is clear. After squares, let's discuss cubes in general. So now I have to find out 102 cube. Let's see the formula first. The formula says base plus 3x, 3x square and x cube. So again we'll define the base here is going to be 100, as was the case of squares. X here will be 2. So let's find out the answer to this first part here, base plus 3x. So this gives me 100 plus 3 into 2 slash 3x square. So 3 into 2 square slash x cube, which is 2 cube. Now what we have to bear in mind here is that both this place here, x cube and 3x square, should have the number of digits equal to the number of zeros in the base. So I need to have at least 2 digits here, not at least exactly 2 digits here and exactly 2 digits here. So if we go by this answers of ours, we have 100 plus 6 slash 4 3s are 12 and 2 cube is 8. I have 2 digits here, so this is perfectly fine. I have 1 digit here, which is 8, so I'll put a 0 here to make it 2 digits. I have 12 and 08, so the final answer is 1061208. Let's try another example. 1014 cube. So I have base is equal to 1000 and I have x is equal to 14. So again we'll write this formula: base plus 3x, 3x square and x cube. Base is 1000, so 1000 plus 3x, 3 into 14 is 42. Now we have 3x square, so this means 3 into x square, 14 square is 196. So I have 3 into 196, and then we have x cube. You need to remember the cubes for the numbers till 20 as we discussed. 14 cube is 2744. So if we solve here, I get 1042. 196 into 3 is equal to 588. So I have 588 here, and I have 2744 here. Now since the number of zeros in 1000 is 3, at this place and at this place I can have a maximum of 3 digits, but here I have 4. So what I'll do is I'll just change the ink color. This 2 will be carry forward to this place. So what I have here now is 744. 2 gets carry forward, 8 plus 2 is 10. 1 will carry forward here, I'll get a 9 here and 5, and the first part remains as it is. So the cube of 1014 is going to be 1042. This is 2 590744. So this is the answer. So now let's find the cube of 202. Here the base is going to be 200, x is going to be 2, and n again is 2, because 200 is nothing but 2 into 100. Now let's see how the formula changes. I'll have base plus 3x. I'll multiply this by n square. We multiplied this by n when we talked about squares. The second part I'll multiply by n, which is n into 3x square, and then I will have x cube. So let's find out the answer. The first part is going to be 4 multiplied by base plus 3x. Base is 200 plus 3x. So 3 into 2 is 6. So this comes out to be 206. 2 multiplied by 3x square. So this is 3 into 2 square, which is 4. And then I'll have x cube. X cube is 8. Again, since 200 has 2 zeros, I need to have 2 digits here. So I'll write a 0 here. I have 08. Here 2 into 3 is 6. 6 4 is 24. Here I have 2 digits already, so no change. Here I'll have 206 multiplied by 4. So this gives me 8 24 24 08 as the answer. So 202 cube is 824 2408. So let's find the cube of 197. The formula says n square into base plus 3x slash n into 3x square slash x cube. So I have base is equal to 200, I have x is equal to minus 3, and I have n is equal to 2. So let's start solving. N square is 4 multiplied by base is 200 minus 9, because 3 into minus 3 is 9, or in fact minus 9. N here again 2 multiplied by 3 multiplied by 9, since minus 3 square is 9, and minus 27. So if we start solving, I'll have 4 into 191 slash 2 3s are 6, 9s are 54 slash minus 27. This gives me 764 slash 54 slash minus 27. Now since we cannot have a minus sign inside a number, what I'll do is I'll strike off 4 from here and write 3, and instead write 100 here. So the answer is going to be 764 5 3, and 100 minus 27 is 73. So the answer is 764 5373. That is all on simplifications. I hope you enjoyed the lecture, and thank you for watching.